Today, a 600 square meter area can take multiple days to clear of landmines and buried explosive hazards. Using the proposed ARCH strategy, this can be accomplished in as little as 21 minutes. The command is to advance into enemy-occupied territory, which is known to be heavily mined in previous conflicts. As our OMV enters a known danger zone, the TDMM activates IED detection protocol, deploying the onboard hammer drones. These hybrid mobility robots feature a durable exoskeleton that protects them against mission-ending collisions. Combined with the gyroscopic gimbal, the hammers can drive on the ground for up to 10 times longer operation. This extended battery life enables greater versatility when carrying some of the heaviest payloads. Equipped with ultra-wideband micro-positioning, the hammers maintain sub-centimeter positional accuracy with each other and the OMV, even with environmental disturbance. As long as they stay within 5 meters of the OMV's power beacon, they can wirelessly recharge for virtually unlimited operating time. To begin the first look advance, an aerial image is captured that becomes the collaborative threat workspace where potential hazards will be shown. The hammers then begin their fast-paced scan to quickly identify potential subsurface threats. For the first time in Army history, road sensor data from multiple robots can be integrated into one perfectly aligned map, thanks to the positional accuracy of micro-PNT. When a hazard is detected, it immediately populates an alarm on the operator's collaborative threat workspace. This triggers deployment of the Shred robot, which begins to characterize the subsurface threat. It discerns between clutter versus hazard, the type of hazard, and its net explosive weight. Here you can see a real scan taken from the Shred rover. The left illustrates the current state-of-the-art technology, which attempts to characterize the subsurface threat after only one pass of the scanner. On the right, you can see how the controlled sweep of the Shred robot enables stitching multiple scans together to form a single, coherent view of the hazard. This illustration simulates how data is captured without the ARCH system. Since it's impossible to view the data as a whole, decisions must be made one at a time based on each individual scan. Conversely, the positional accuracy of micro-PNT enables stitching multiple scans into a single map for faster, more informed decision-making. Apart from the patented strategy employed by this team, no other fieldable solution exists to reliably stitch together subsurface data. This is true both for the one robot seen here, as well as multiple robots scanning simultaneously, as shown in this animation. This leverages the Army's investment in Shred, while micro-PNT allows the Shred data to be placed in global coordinates, extending the same positional accuracy to data collected by other systems. What's more is that unlike GPS, micro-PNT is resistant to jamming. It works under forest canopies, in the shadows of buildings, and even underground. Once the Shred rover confirms the presence of a threat, it initiates IED defeat protocol. During the time Shred characterized and neutralized the hazard, the hammers continued their first look advance, identifying several more alarms on the CTW dashboard. In summary, by starting with a fast-paced first look advance, the Shred only needs to be deployed when a potential threat is identified. It then uses the precise positioning of micro-PNT to characterize the hazard, discriminate false alarms, and neutralize the threat. Using a single robot equipped with micro-PNT, experimentation at Fort Leonard Wood resulted in a 4x improvement in advance rate, 1 false alarm per every 2,000 square meters, and an increased detection rate from 85 to 95%. Using the first look advance, it's possible to reduce total detection time from over 5.5 hours to just 30 minutes, representing an 11x improvement to advance rate. Perhaps the greatest advantage of ARCH becomes clear when we examine neutralization. Both the Army Research Lab and Geneva Humanitarian Demining agree that handheld detection and neutralization takes 1 hour for every 20 square meters. This equates to 30 hours for 600 square meters, meaning ARTS is over 40 times faster than traditional handheld clearance.